Hello and welcome to another session of Pistonics, the series where I build a little program. Right now it's catchit using Piston. And it's Byron speaking. In the previous session, we managed to set it up to create obstacles that are having a velocity and are just getting put far away enough from the player position. We implement everything to be relative to the size of the playing field so that, we can play around with that as well. So I think that's very important, not to hard code anything. If you hard code something, then usually it's scaling factors or something, coefficient, and stuff like that. Yeah. Good. So I was thinking maybe max score, best score is better for this. Why not? But that's just a minor thing. So the next thing you would want to do is to make these obstacles move, right? And we can as well, we can intersect here. I don't know why there is some spaces. We can do this movement here. If you like, we just stop it as soon as we figure out that something is happening. So the obstacle was hit, or the obstacle hit the player. Yeah. Move and collide the obstacles. Yeah, so that's just one part of it. We iterated once here. Why should we iterate it multiple times? I don't know. Game state wise, I think that's okay. So yeah, it would be great if, we have a velocity and that's cool and stuff, but it would be great if we had a notion of time here. And I think the update, in terms of seconds, right? Because otherwise you might I don't want to work in ticks because ticks depend on the frame rate and this stuff we want to change all the time. Or that might change if the computer is not fast enough for some reason. So no, right now we are tick dependent, and if you want to do movement, that's a no-go, I think, for any game. Let's keep control, shall we? So update arcs. I think these ones possibly have this information. Oh no, that's not the right help. That is the one. Update arcs provides update arcs which provide DT, delta time, in seconds. And that's exactly what I want. F64. So let's get the delta time. Give me the delta time. Delta time is an F64, and now we actually use those arcs now. Awesome. So I can make it visible again and hand it over. Arcs DT. Cool. Thank you very much. And now we can use the delta time to scale our velocity. And then we will see if the velocity makes sense. So yeah, let's change some positions, shall we? So these things fly along their velocities, and I think we just want to scale this. Vec to scale. Yeah. We just want to scale this with the time data. So in 1 second, it basically is as fast as the velocity. This is what we would do right now. And I'm not sure if this is the final speed, if this is a good speed. Probably it's too slow, but that's how I would do it. So obstacle, object, position is vec to scale. I don't have that yet. Of obstacle, object, position, and the delta time. So that is that. Let's bring it in. Let's bring in back to scale for maximum happiness. There we go. Cool. So in theory, the balls move even though they will fly out of the game relatively fast. Cannot assign to immutable field. Yes, true. Yeah. You know what? Let's advec them first. And then we do the scaling, the intersection test. Let's do it like that. Because that could change it a bit. I think that's fair enough. Good, so then we say game over. And abort. but we move everything first. So here we go with ida mat. Now we should have a mutable obstacle that we can change. There we go. Cool. Let's see. Where's the ball? Oh yeah, I'm doing shit because I am assigning. I wanna, like to add the position and the scaled velocity here. Do I have vec to add? No, vec to add. So this is what I mean. This is why this thing popped up in the top left corner. And I managed to get the parentheses all wrong. And yeah, curious. How fast is this thing? Quite fast. And why does it always fly in the same... Okay, it hit me. In the same direction. Okay, these things are quite fast, that's for sure. Let's make them slow. But why is it always flying in the same direction? There should be... This makes no sense. Because I am generating the velocity here from random values, right? Ah. No, wait. No. Oh. Yeah. Actually, from minus to plus, let's make it like this. So let's call it minus, and here we do the same thing. So that could be one reason, but still I would have hoped. Yeah, so this field coefficient, I think now that, we have to half it now at least to get the same thing, and then it was still a bit fast, but we shall see. And I really want to fix this game over thing as well, because I might get hit relatively often. Damn it! See, these things are fast. So let's do it 0.5 or something. But what? Wow! Even come on, dude. Fast is. This is crazy fast. And they still go into the same direction. What the heck? What? I'm not happy with that rightness that happens there. It should go to the left at some point. Up, down. What? Oh, maybe I wanna... Well... Maybe I'm doing it wrong. Maybe I wanna... Yeah, just set it from -1 to 1. And then do the scaling later, huh? Yeah, I think that probably is more like it. Okay, so let's go -1. So the field coefficient comes after the randomization to 1. And... Or we scale the velocity in the moment we apply it. What about this? I think that could be something. Yeah, I think that could be better. Since we have to do the scaling anyway, you might as well do it later. Okay. So that should, if that doesn't yield velocities in all possible directions, then I don't know. All right, so here we go. We scale. Oh, we scale position. Damn it. This explains. So anyway, so now we have 0 to 1 velocity, and we scale it with the... And we had the field. Yeah, so we could still do it the same way, right? We scale it by the delta time, And the velocity, we could do the scaling. Actually, we could do it here. Velocity 0 times equal how does that feel then? No, actually I liked what we had before here. Doing it by the field coefficient. Yeah, let's do that. So then we get the proper range already and don't have to clamp it another time or put it into range. I like that much more. So it's minus and plus. Let's just copy the entire thing. Put this to 1. And that's better. Velocity field coefficient might be too slow now, but we will see. Now it should go in all directions and have various velocities. Yeah, that should be better than before, at least. Let's see. No! Obstacle velocity. Right? Right. Cool. Now, the big moment. Moves, but very, very slowly. Yeah. I think that was me here. Maybe put it to 0.2. That's 4 times faster. Maybe 0.3. 0.4. After all, we talk about this. This basically means at most it can be as fast as 1/4. 40% of the screen. 50% of the screen per second. Maybe it should be able to travel 60%. This is a coefficient that we might actually want to change at some point when the level rises. So, new balls can even be faster than that. So we just have a starting point. So initially they might be relatively slow here. And then it just gets faster and faster and you get more points. Yeah, so that's all kinds of directions. And I already have to be careful not to bump into one of these. Yeah. Cool. And now, they're still in the game, right? They just fly off the screen and are never drawn. So let's not think that it's less work for the game. No. So that's now reflected at the corners here of the screen. That's the cool thing. That's super easy. Even for me. And usually I have difficulties doing that kind of stuff. But yeah, let's advect it. And now we clamp it into position, right? We should clamp it. But if we clamp it, what should we do? I think I want to inverse the direction now if necessary, and then I clamp it into position. So last thing, clamp it. Object pose is self clamp to field, which is s.field. Then the obstacle objects half size and the position. Like that. So now it's clamped at the end, and now we do the inversion. Basically check if it is damn it, can I? Let's work with that new value, shall we? Let's pose be this. I think that's much easier, much nicer. Then we can even put this here. Then we can put the new position here, and there's not enough space no matter what I do. Fine. Clamp it into position, and now we can basically verify that this position is still in the game. If it hits a wall, we invert the respective axis of the velocity so that next time it flies into a different direction. And also we will clamp it into location so that it should look good, I think. So if pose 0 is smaller, pose 0 minus half size. Let's half size Oh, let's get the object, shall we? Because then we can do the left and right thing. Yeah, let's get the object instead. So here we have a new position that we shall set to the object that I shall get here. Let mud obj be object obstacle dot, actually, yeah, like this, huh? Mud object. So now we can take obj here and everything will look better. We can assign it here. And in that case, we also want to set it, right? And we clamp it later. So basically, you want to set it to use the actual value, to have basically access to the left and right. That's why we set it first, which also means we can clamp it. No, wait, if we clamp it, then we might not get the boundary detection, right? We basically want to overshoot that thing a little bit. If we clamp it, we don't ever overshoot, so we can't do it. So let's say obj position is this. And then we clamp it. Later, then we set the size. That's all much nicer now. Okay, so let's see if that actually works. It should. I don't want to run it. Okay. Anyway, boom. Game over. Oh, look. That looks weird. We hit it, but we don't see it. So our state management is a bit poor here. Even though we set the state, that's weird. It seems that we don't draw the latest state, even though we obviously must do that. There's no other way, but it doesn't look correct. Otherwise, we would hit it, right? Maybe the detection, the collision detection, isn't good right now. Maybe it takes. Yeah, maybe it's not good. That should obviously be perfect. Oh. Circle and circle. You want to have that correction, that thing correctly done. Right now it's not correctly done. Yeah. So that's something we have to do. Let's mark it, shall we? We fortunately have the ability to do that relatively easily. So we just match on that and match on self shape and other shape. And we say if collision shape circle and collision shape circle come together, we have a special one that we shall implement. Otherwise, we have the standard one that kind of does a rectangle and rectangle and whatever is in between. Like this, huh? So that should already be better. I mean, right now I basically disabled collision between the obstacles. So let's do the flipping here, the velocity flipping. So whenever we go past the right side, if obj right, or let's start with left. Left smaller than, or equal. Smaller equal than 0, then obj position, then the velocity is changed. Then obstacle velocity 0 is inverted. So the x velocity changes and goes to the other direction, while keeping y the same, so it still goes up or down, whatever. So I think that should do it. So now, if my bottom is smaller than 0, then we go off the top. No, wait. If my top is smaller. See? Good that I have these functions. Helps me to get this stuff right. Hopefully. I have chances. So then velocity 1 is inverted. Then we go the other way next time. And remember, we clamped this stuff, so if we overshoot a little bit, which can happen during the advection, we will just put it back in place. So now, if my right is greater or equal, then the extent greater or equal than then the extent of my field. So that's as field 0. Then we shall invert x again. It's really just like that. So I guess we can also work with elifs, so we test the right thing. Because left is either there or there. It's never on both sides. Whereas top and bottom can also happen at the same time. So bottom is greater or equal to my S field 1. Then we invert the y-axis as well. Cool. So that should be the logic we need to get all the collision detection with the field. Right. And at the end, we clamp it and we are done. So let's see. Does it run? 242. What's the problem? Place this code inside a block. Maybe like this, huh? Can I move out of borrowed content? All right. True. Can I do... no. I can do this. No, wait, what happens? Can I do this? No. Then I have to do it like that and match against this, huh? Okay, it doesn't need to be mutable. Cool. Let's get a few balls in the game. Fortunately, I'm invincible. Yay, stuff happens. Woohoo. It's already? I mean, ooh, there I got hit. I don't get too many white balls though. Maybe I want to increase the chances a bit. Maybe making them very rare is a good thing too. Ah, there's one. And maybe every 20 balls, but maybe every 10th ball we want to have that. Cool, that totally works. No ball is flying away anymore. Does it collide with the right thing? Yes, it collides with the lower boundary. So we can be here and be safe. Nice. Alrighty. Where is my ball creation? The kind. Let's make it every 10th ball. Something like it. Okay, cool. How much time? 24. Okay. That is that. Let's get the collision detection back and have proper detection for circles, basically. So you could say if the distance between the centers of two circles is smaller or equal to the half size, which is the radius of the circles, then they collide, right? And we have objects here, so we can say vec lang, vec sub, between self position and other position. If that is smaller or equal to self half size plus other half size, right? Yeah, I think that must be right. Looks good to me. So that is that. So now we should have collision back. Vec sub, vec2 sub, it's called. Vec2 sub. Oh yeah, it doesn't need to be mutable. Let mut obj. Why is that? Oh, because I'm assigning a mutable borrow, and I don't want to reassign that object, right? So does it work now? It does. Cool. Here we go. First one, second one, and there we go. Now it's precise. So that intersection is just because it was moved first, but that totally works. And now let's watch for spacebar or something. Key press events. There was, yeah, we have code for this. Piston falling sand. No. Piston falling sand source main spacebar. So here we go. That's how that goes. Button. Just copy it. And this way we reset the game. So let some button be a keyboard key. And if the key is, and there's no information about whether this is release or yeah, that's press, so probably we have release arcs as well. So we just check for the presses then. So then, you know what? Key is key space. And then, if that is the case, we reset the game. And we reset the game by saying app engine reset. And now I feel like I want to keep the entire field because I don't want to recompute this. Where do we compute the field? Here we do. Yeah, I don't want to recompute this. Or I want to put it into a function to prepare for later. Yeah, let's do this. Let's put it into a function. Fn field compute field. This gets a width, which is U16. Height U16 produces a beautiful field that we can use for anything. So that shall be width. Oh, we need a text height. Nah. Let's make it the... damn it. I still have to compute it then. Or we take the glyph cache, maybe. Yeah, let's take a glyph cache in there. So that we can get the text height specifically. Do I use the text height for anything? I do. Yeah, shit. So let's take the text height. What type is that, by the way? Yeah. It's F64. Yeah. Let's call it a scalar then. Do we have scalar? We do. Okay. We will definitely need that later as well. So let's compute the field. Width, height, and text height. And there we go. Now we can actually recompute that. We have all the values that we need around. The reset needs a field, so we compute the field again. Could also make it a function on our app. Why not? We have it. This makes the signature easier, simpler, and might not, well, a little bit simpler, but might be easier to call. So it's self text height. Fortunately, we have this cached. Hopefully this doesn't change with the resizing of the screen, but I don't think so. No, that doesn't change. Okay. That's cool. That shall do. Let's make sure we call it correctly. Oh, look. It was actually a good thing. Damn it. To have it, because we are at construction time here. And yeah. Let's keep it as a function in the public space. I didn't see that in time. So yeah, let's compute the field again, which is width, height, app, text, height. Okay. That is that. And we can keep going. Let's see if that works. Yeah, sure. We don't have anything here. Undeclared type name field. Really? True. That's a playing field. Maybe that should be said. Maybe I want to rename this. Field. Yeah, so where's that used, that type? Wait a moment. It's an extend. Damn it. Yeah, well, then we are good. We just have to use the right type. Yeah. I got myself. I bit myself. Or I shot myself in the foot. That's what you could say, I think. Just because the terminology sucked a bit. Field extend, playing field. Well, it kind of makes sense, but I got it wrong anyway. Good. So now we compute the field. We reset. All we need is the respective thingies here. We need key. Let's see where that stuff is coming from. Undeclared. Didn't I fix this? I think I did. Oh. Extend. Yeah. So now the keyboard related issues. Unresolved enum variant structure const keyboard. Where is that coming from? How can I get it? Input. Makes sense. Piston window. Where's is it piston input? Let's see. I think it is piston input. Cool. And this just re-exports probably this backend thing, does it? Seems to be its own crate. No, it's a module. Anyway, so here we have the keyboard, and probably the key is there as well. Yes. Let's have it. Yeah. There's no keyboard in piston input. Ah. It is a module. So where's the type? Piston input button keyboard. So what is button? Ah, that's an enum. And then you have key. All right, piston input button. Button, key, and I think that's all, right? And there's no press arcs, but there's a press event that we want to import as well. Not super trivial, I mean not super easy, but hey. Oh, so it's 129. Consider removing the semicolon. Thank you very much, my dear compiler. I love you. Cool, no errors. And now space, and it starts again. Keeping my score. Let's try to get a max score here, shall we? It's a real game now. I mean, the only thing that's missing is the only thing that's missing. Oh look, actually it doesn't collide with these. Yeah, best score 150. So the scoring mechanism we want to improve, and we want to implement the different ball types. And I think before I call this a session, I would like to print something. So if we are game over, we say press space to restart. So otherwise, draw some text into the center of the frame. Text draw. Press space to start for new game. And this should be in the center of the screen here. And it is just what it is, a string slice. That's the font, that's the cache. The matrix is what we are interested in. Actually, sure, this puts it to the bottom. So what we want to do is C transform trans, and then we put it somewhere in the center. Width by 2, width as scalar by 2, and the same with Y. And let's see what that does. Height as scalar by 2. Damn it, incredible. But we are a bit offset anyway. No, like that. I hate this reformatting stuff. I hate it. I would so use a tool to do it just so that I don't have to. So let's see what happens. Let's go game over. And as you can see, oh, damn it. Yeah, you want to show the last state, but we want to know what it is, right? Right now we don't know what kind of state we show here. So, oh yeah, and the last state has to be set to 0. Because we don't need to keep it, right? App last state is none. And I think we can use the last state to determine if we are or not game over. So if last state is some, then we do that. Yeah, I think that's what we should do. It's kind of an unnecessary check here. This entire thing, it's okay, but it's a bit, it uses more cycles than it would need to, and now we check for it again. But on the other hand, this is really nothing in terms of cost compared to anything else, so I don't mind. So now I should see something if I go game over. Press space for new game. Yeah, now we have no idea how big that string is and stuff. So we can so it places it in the center, but obviously it's relatively long here, and now we need the size of what it would print in order to move it right into the center. And yeah, we can do that. The text, does it have a width? I think it might even have a width function here. Oh no, it's not that good. But each character has a width, and we could basically compute it. Maybe there's a function for it. Types width, type used for width. What? Okay, just a scalar. Character width, yeah, this is what we, oh, no, that's the line width. Also not for us. Well. Yeah, we could have a function that does that for us. This also means, let's make this a constant. And then we can pre-compute this basically. Const new game text shall be a static string, which is press space for a new game or whatever. New game text. Like that. And now we can compute the size of that thing later. Let's put in a scalar. New game. Well, let's damn it. Let's have a function that does it. Let's does it on the fly. I don't really mind. And then text width. So that takes a self here. Oh, damn it. We need actually a mutable self, because we want to change the cache. And if you want to do this, then we get into trouble in that situation. So yes, we can as well make it a free function here. And then text width, taking a cache, a mutable glyph cache, which has to be static, right? And it takes the text and it returns a scalar that is the size of the thing. And all we would have to do is ask for the characters with the font size that we chose for the game. So for C in text chars, that might width be 0.0, return it. Now we compute it. So width is this plus cache character font size, then the character, here you go. And then we do width. I think that is something sensible that we can use. And that is that. Good. So we have a text width function now that we can use here to get that into line. Damn it. Once again, I waste time to reformat. Okay. So width by that. So here we have the center point, and then we basically just, I don't care if the height doesn't really match, but here we really want to put it so that the width makes sense. The width of the where we have the game cache font fire bold. That's already a mut, right? Yes, so we can just use it. A mut borrow. And what was first? Cache, and then the text. New game text. Damn it, not even that fits into that line. Yeah, that's annoying. Anyway, and by 2. Because after all, we don't want to move it all to the left, just half of it. Yeah, that makes sense. And with a little bit of luck, this actually works. Maybe, maybe not. No. Oh, as mutable. More than once at a time. True, it wants to draw it. Yeah, so we have to get the text width. Let W be this. We have to get it first. And then we can put it here. And then we should be fine. Probably it's easier to read that way anyway. So that looks good. And now, boom. Space for new game. And we have a new game. Voila. I actually like it that it stops for a moment, even though it doesn't really have to. It could indeed remember all the extra trouble we went through, even though technically, I still kind of like it. I mean, for future, I see that they leave trails maybe, and then it would be cool if you could estimate the direction of these things and how fast they were, and you kind of have a snapshot of what happened there and how terrible it was. Yeah, I think I want to do this like that. Now that I have it implemented, I want to keep it. And yeah, so the next thing is, I failed. The next thing is there are many white balls here, damn it you. Maybe I should bring this down a bit. But yeah, that's gameplay stuff, that's tweaking. I think the next thing should be to so cool to have it now. It's even the debug. Damn it you. And again, the next thing should be to implement this decay stuff so that you have so that these things go transparent over time. So that's the next thing, I think. So thanks for watching and have a great day.